Welcome students. Now we will see pressure exerted by liquids, force and pressure exerted by liquids. Okay. In liquids also one force is acting, that is called as buoyant force. So what is the name of the force acting on the liquids? That is buoyant force. Okay. What is buoyant force? What's the definition for buoyant force? When an object is immersed in a liquid like water, the weight of the object acts in the downward direction, and the liquid also exerts some upward force on the object. This upward force exerted by the liquid is called buoyant force. Okay, so what is buoyant force? The upward force exerted by the liquid. Okay, and this phenomenon is known as buoyancy. Okay, now the upward force decides whether the object will sink or float. By measuring the buoyant force, we can tell whether the object will sink on the liquid or the object will float on the liquid. Okay. How can we decide that? If the weight of the object is less than the upward force, that means if the weight of the object is less than the buoyant force, then the object will float. Okay. Suppose if the weight of the object is more than the upward force, then the object will sink. Okay. Thus, we can tell whether the object will sink or float on the liquid. Okay. Listen. Okay. Now let us see one experiment for pressure exerted by liquids. Okay. Liquids exert pressure not only on the base of the container in which they are kept, but also on the side walls. Okay, liquids exert pressure in the bottom of the container as well as on the side walls of the container. Okay, so the pressure depends on the depth of the point of observation considered in it. Here the pressure depends on the depth of the point of observation. In liquids, at what point we have to measure the pressure. Then what is the depth of the point of observation? Okay, so here pressure depends on the depth. Okay, for that we have to see one activity, how pressure depends on depth. Okay, for that we have to take one plastic bottle, then we have to punch 3 holes on its side in the same direction. This is the plastic bottle. Here 3 holes are put in the side in the same direction one by one. Okay, but at different heights. The 3 holes are at different height. Okay, now we have to pour some water into the bottle and let it flow through the holes. Now the water comes out through the holes. Okay, now we have to observe the flow of water. When we see the flow of water, water from the lowest hole comes out with the greatest force, and the water from the topmost hole comes out with the least force. Okay. So what is the reason for the variation in force? Why the water comes out with greatest force to the lowest hole and the water comes out with least force from the top hole. So what is the reason for the variation in force? Okay, because in the depth of the lowest hole is more. The depth of the lowest hole is more and the depth of the topmost hole is less. Okay, so what is the reason for the variation in pressure? Here the depth of the holes are varied. Okay, the lowest hole has more depth and the topmost hole has the less depth. Okay, that's why in the topmost hole the force is less. In the lowest hole the force is more. From this activity we confirm that the pressure in a liquid varies with the depth of the point of observation. Simply we can tell that when the pressure increases when depth increases. Okay, so when the depth increases, pressure also increases. Okay, then we have to see another activity. Okay, Here the pressure depends on the height of the liquid column. This activity tells pressure depends on the height of the liquid column. How can we prove that? For that we have to take a glass tube that is open at both ends. We have to take a glass tube which is open at both ends. Then we have to fix a rubber balloon at the lower end of the tube. One end only we have to fix a rubber balloon. Then through the another hole we have to pour some water into the tube and observe the balloon. Okay, now pour some more water into the balloon and again observe the balloon. Okay, when we pour some little water in the balloon, the shape of the balloon will be less. Okay, when we pour more water in the balloon starts to bulging outwards. Now the shapes becomes more, the balloon blown up more. What's the reason for that? When we pour a little amount of water, the height of liquid column is less. So there is less pressure inside the balloon. Okay. When we pour more water in the balloon, now the pressure increases. Okay. So when the height of the liquid column increases, pressure also increases. That's why the balloon starts bulging outwards. Okay. From this activity, we are inferring that the pressure exerted by the liquid column at the bottom of the container depends on the height of the liquid column in it. Okay. So when the height of the liquid column is more, pressure will be more. If the height of the liquid column is less, then pressure will be less. Okay. Thank you.